Hi guys, we are back for another episode of the Technic Connect Behind the Robot podcast. We're joined with Kevin, CTO and co-founder at SUIND. How you doing, Kevin?
Hi Adam, it's great being here. I'm doing great, thanks.
Good stuff. Thanks for jumping on with me. I appreciate we've just got to talking, but I'd like you to first introduce yourself, introduce SWIND, what you're responsible for then, and ultimately your role in essence.
Cool. Yeah, so we are SWIND. We are pretty as much an early stage startup in the agri-tech domain. And what we really want to do is basically tackle the challenge of crop losses across the globe. And we do this using the world's smartest agricultural drones. So our key USP is really building fully autonomous, smart systems that can really navigate in any kind of terrain. And as you can imagine, agriculture is a super diverse, crazy kind of environment. So we build drones that can really tackle this challenge and help rural farmers across the globe. So really talking in the backbones of like Indian agriculture, sugarcane, rubber plantations, like the really nitty gritty, messy stuff where the biggest problems in the world are. And that's where we operate and try to make the biggest impact.
So I suppose what was the reason that you dove into India?
Actually, my co-founder is from India, so we, of course, they have like this nice direct connection to it. But also, India is the second biggest producer of pretty much everything when it comes to agriculture, of course. So massive market, massive potential to make an impact, and also a lot of pain points there. So we didn't want to build a product that is just creating like a kind of a greenwashing impact in, for example, like Europe, where you can make a little bit of a change, but it's still kind of limited. So we wanted to create something where we can create like actual measurable big impact. And to create impact, you should go to an impact nation where doing 1% in India would be magnitudes more significant for like the environment, the globe, for food production, for people's lives than doing, for example, in Switzerland, where we got started. If we do 100% efficiency in Switzerland, it doesn't even compare to just doing a little bit in India. So that was also one big reason for us to go there. And funny enough, also India was just a lot faster in adopting drone technology for agriculture. They were really they wanted to have it. The government was supporting it. And there was this big pain point there that you could really solve with it. So it was basically a bit of a like from a multiple angle kind of decision for us where everything just pulled us into this market basically.
Perfect. And
Yeah.
what's your responsibilities like at SWIND as well?
Yeah, okay, so I'm one of the two co-founders. So we started like really small initially, just two guys together, like me and my co-founder, and then over time we slowly grew. Both of us are full-on techie backgrounds coming from robotics. So we both studied robotics at ETH here in Zurich together. And now he is the CEO, I'm a CTO. So my responsibility nowadays goes from anything from actually still I do still do a lot of development on the systems, anything from like the robotics, drone code, cloud infrastructure comes not we of course have we're building hardware products, so working with our team to get the hardware to a certain standard, making sure that all of that is properly done. So I would say like this whole like everything that goes into the technology world, but then comes testing and supporting the team, project management. So I think it's this typical founder responsibility where you kind of have your fingers a bit
Hats.
in everything.
Yeah, wearing a million hats and putting out a million
Yeah.
fires. Yeah.
Yeah, we're still super small. I mean, we are under 20 people still. So there's like everybody has a lot of responsibilities. Our whole team, everybody has to wear multiple hats, do different tasks. But I think that's also a fun part about doing a startup, that you do have these different kind of responsibilities and not just one niche job.
Definitely. And you touched very early on in the conversation on a topic that we do get a lot from startup leaders as well, that your product has to solve a real world problem. Otherwise, it's how does it contribute to anything? How does it work for a sustainable business model unless your product is doing some work really in the real world? Perfect. What's your out of work life like? What keeps you grounded just with beyond Swind?
Yeah, I mean, as a startup, so of course there you do have a bit more the longer working hours and into the weekends, of course. But I normally do try to keep like also a bit of an active lifestyle. So a lot of nature. I think, especially in this tech role, robotics, like during the day, normally, I mean, it's quite normal for me to spend like 12 hours a day just looking at a screen. So I do try to balance this out a little bit. So as much as nature as possible. So I have this amazing hyperactive dog. She definitely pulls me every day into nature. So just going out, going, I don't know, for walks, runs. I don't know, I love doing like yoga next to work. So try to do this like most days. And recently started climbing. So just getting that nature aspect in. And of course, here in Switzerland, the best thing you can anyway do is just going like hiking and into nature because we're surrounded by mountains. Living here in Zurich, you just have like a at most an hour drive, and you're in the middle of like the most amazing scenery. So that is of course something I try to get in as much as possible. Just getting out there, getting this balance between like this like really technical screen time and then grounding yourself a bit and
Hmm.
more like a nature part.
I suppose I wanted to touch, Kevin, on any kind of, is there anything personal values wise or experiences that have really pushed you into the robotics industry? Like, where did that interest in robotics come from?
Yeah, I think I mean I honestly, I was always like quite tech interested. So I don't know, as long as I can remember, I think it started probably with Legos, just loving
Yeah.
building stuff with friends. Also, funnily enough, my oldest friend, who is also an engineer now, we always used to play Lego together. So
Hmm.
maybe this does
Yeah.
something. But actually, I did initially want to go into aerospace, so robotic design. My grandfather is actually, he used to be like a physicist and engineer, and he worked in like the German aerospace program, then the European one, and etc. So he was always, I think, also influencing me a bit in this like tech realm. All his presents were always like very tech related, rocket related, and something. So,
Hmm. Yeah.
um, no, but then during university, I don't know, doing when I started doing like the control system. So I didn't really plan it that much like robotics. Like I said, it was more like rocket design. And then I started going into control systems. And after like the half of the first semester, something in my brain just kind of clicked and this whole topic started making sense. I must admit, initially when I started control systems, initially I was a bit like, I didn't really get how everything worked, but at some point it just clicked, and then I got this real fascination into it. And then I started just like getting all the courses in there and starting building more things in robotic anyway. And computers always fascinated me, and doing things in computers, just like being able to build systems from scratch up. So yeah, that just kind of led me more and more into that road. And then also doing my bachelor thesis, I had the privilege to really work on one of those like industrial ABB arms. I was the first in the research lab where I joined to actually do a project on that arm, and there was like super much like insane fun just having like this really industrial product that as a student you could never even like be able to afford, and then you could work on that. And yeah, I think just this idea in robotics that you basically have a blank slate, and from your imagination, like writing the code, building the product, you can really create a live thing that actually interacts with the world, does things, and you have like this god controlling it and doing making it do things. Then you see it come to life. This is always like just super
Yeah.
fulfilling and fun
Nice. I
and
think that's
challenging.
every engineer's. I think that's every engineer's dream, really, isn't it? Is to work on something inside a computer and see it come to life in real life, basically, and seeing the product of your work actually in front of your own eyes. Especially that opportunity to work on the ABB arms as well. That doesn't come along very often, does it? So,
No, I don't think so. And that's actually, I think, one of the really cool things about the university like ETH where I went to is that they do have these like randomly, like, I mean, super expensive things. Then they let students do projects on them. So yeah, I get this like real, like, you can actually touch proper stuff. The projects are really like sometimes even like connected to industry and something. So it's not just I don't know, doing the same project that every student does in every university, but you have quite unique things you actually do get to work on, which is kind of
yeah. No, nice. I think you've brought me really round well to my next question, to be fair, is what's your education like? What's your educational background? Did you always see yourself working in robotics from, I know you said from the first semester you kind of had that switch, but what was your educational background like, and was it really pushed into robotics from there then?
yeah, so I mean, like I said, I mean, normal high school in Germany. I did have like the like really like the focuses on all the like science stuff, like math, chemistry, physics, that kind of stuff. Just it was an interest for me anyway, so it was not like, okay, I am planning to go that route. I have to pick and choose, but it was anyway kind of fit together. Then, like I said, went for the engineering master, a bachelor's, and then the robotics master. It's just a specialized engineering master, basically, where you have a limited set of courses. And then really the master focuses on the robotics topics, which for me was then really cool because at that point when I switched into the master, I knew I wanted to work in robotics.
Hmm.
So having just this like focus directly into that direction was pretty cool for me.
Yeah.
And yeah, then I think what was pretty nice though in the education part at the university I went to, like the ETH here in Zurich, is really I think the projects and the projects in the research labs I was able to work on. So, for example, I went to like the robotics perception group, and it's like this amazing drone lab. They do this AI computer vision research for drones, really making drones fully autonomous. And there we like really getting this exposure then to like all the PhDs working on this, doing like state of the art research, having like this crazy amount of knowledge, and you get as a student get thrown in there. Of course, compared to that, you have like no clue what you're doing at all. But you can talk to the PhDs there. You have your problem, your thesis you're working on, and they can then guide you. You can brainstorm with them. They give you ideas. Like my supervisor, he was really amazing to work with. We had like this constant like brainstorming sessions on how to best basically come up with a system that works. So I was working on like a morphing drone on the first one, and then like a super dynamic obstacle avoidance system on the second project. And then we really came up with this really cool solution. So we were really working on like the next level things. And I think that is in education, for me, the most valuable part is really this like hands-on experience, because theoretical stuff gives you like a base understanding of things, but I always find the most learnings come from actually working on a project, on a
Hmm.
solution where you have to go into every nitty gritty detail. And that's for me personally where I always learned the most stuff, just doing these kind of projects. And then, of course, afterwards in the startup journey, where this is non-stop education basically.
Yeah, I'm exactly the same, to be fair. A lot like kind of practical application of things, doing stuff in my hands first, making sure that I know how things are put together with my
Mm,
actual hands. You know, if I'm just reading about it in a book, I can't absorb it as much, you know, if that
yeah.
makes sense. I think that that's the benefit you get from going to a school like ETH as well. You know, what's some kind of career milestones or projects that you've been involved in that you're particularly proud of? Do you think there's anything groundbreaking that you've worked on, is basically where I'm getting with that?
I mean, back in the day, university, I thought we did groundbreaking stuff, but compared to what we're doing nowadays, I mean, this really just pales. So I think really, like, for me, like I said, it's university into the startup world. But I must really say, I think for me, like a milestone that was really groundbreaking in our startup journey, and where I really realized, oh, what we're doing is something different and really brings a unique and powerful solution into the world, is when we the first times, or like every time actually nowadays, that we put our system into like the rubber industry. That was just crazy. I'm not sure like if you've seen images, or anybody listening to us has seen images of how a rubber estate looks like.
Yeah.
It's basically, I mean, for example, we did in Kerala, India. So they also grow a lot of, but it's this hilly, mountainous region, and they grow rubber trees. They grow between like 10 and 30 meters high, and it's in a completely hilly, remote location. And because the roads there are just so horrible in these estates,
Yeah.
so you just have a couple of small spots where you can take off, but you're taking off from a small clearing in the middle of a massive forest, and you basically just look up and you see but like the top of the trees. So after the drone starts, you don't even see the drone anymore.
Hmm.
So it's completely beyond visual line of sight, and because you have so little like areas where you can start off, the system has to by itself fly for roughly like sometimes even up to a kilometer, and it's a complete forest basically. So crazy different tree heights, ditches, canyons, hills in between. So you fly over a hill, so the drone is suddenly on the other side of a hill. You don't even have a direct line of sight anymore, so remote control, you can just forget any of that kind of stuff.
Hmm.
And we normally use just like a spotting drone, just like a video drone that we put up high in the air so we see the systems during testing or during the missions, also grabbing some nice video footage there. And when I saw the footage of what the drone was doing, how it was navigating in this like insane environment completely by itself, and you just have to let it do its thing basically, because you can't really intervene at this stage because it's so remote. And it just worked. And
Hmm.
actually, the team was in the field, and I stayed in Zurich, basically in the office. Yeah, it's like a 2 week operation. So they have monsoon twice a year, and then they get these massive fungal outbreaks. That's why they
Hmm.
need to spray the entire, basically, rubber forest, you could call it. Otherwise, the trees lose all their leaves, and then the latex production, of course, goes significantly down. So right now, they do it with like from the ground up like shoulder sprayers. So they spray from the bottom 10 to 30 meters high into the tree. So you can imagine how bad this works. So drones, of course, they're just flying over rapidly, spraying from the top down. It just works so much better. So we had really good like results from the efficacy there. But for me personally, as an engineer, like having worked on the system, just having seen it fly there, it was just like a crazy thing. Like I said, I took 2 weeks off, or like I cleared my schedule for 2 weeks, and I was just like ready to basically do remote support because I imagined everything going wrong, and I didn't hear from the guys for 2 weeks. At some point, I was like, "Hey, what's going on?" They was like, "Yeah, it's all good." This was like it just works, and that was just for me the epiphany moment that we like what we are building is actually a product that's working, it's doing its thing. So that was cool.
Perfect, perfect. Really, 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 really good analogy. To be fair, really good story on seeing your product come to life, and at what point it's like the eureka moment, really, isn't it? Where something's like we're actually doing something here.
Yeah,
I think you only
because
really get that feeling in a startup company, don't you? Really, like I don't think that level of excitement you can get from more like like a big giant of a company. I think that has to be like your baby.
yeah, I think so as well. And I think as an engineer, it's like because like if you really work deep into the product, like every system, but also, okay, what is it sensitive to? What are the challenges and what did you solve, etc. So you always have this like problem mindset. You see all the problems because that's what you tackle all the day. You don't work on the stuff that works because that stuff works. So you always work on the problems. And so I think you get a bit also this not pessimistic, but a bit this problem mindset that you just expect the worst all the time out of the product. And then at some point, just having things work is just like, it's a kind of a crazy experience, actually, to be honest.
Yeah, yeah. I imagine. I suppose a bit of self-reflection from you, Kevin. Is there any kind of advice you'd give to yourself before either starting your own startup or jumping into the robotics industry? Any key lessons you've learned, I guess?
I think starting into the startup, definitely it's a lot tougher and longer journey, especially working in hardware.
Hmm.
I think a reason it's called hard. I think I'm not sure if I would have started if I had known how challenging this kind of like startup road could be. But I'm glad I did start it. So definitely no regrets there. But I think just like knowing as a startup founder what all comes your way, there's a lot more challenges to be solved than you could imagine initially, especially if you come out of university. You have no clue what you're getting yourself into. And I think that's a good thing. But being a
Yeah,
bit
it's part of the
blue-eyed, I
fun.
think it's always good to start something because otherwise you might not even do it. But I think also in the hardware industry, developing something, I think really this thing, number one, testing is so important. Like just like
Hmm.
really stress testing everything. For example, for us, like really when we started giving our systems into the hand of not engineers using it as part of our engineering team doing test missions or something, but actually people using the system just like a tool that it's supposed to be in the real world. Nothing beats that in the learning. So just this like really this actual not fake real world but actual real world, putting it out there, having operators using the system, this is where you learn the most. And I think that's when your system actually has an opportunity to mature, because that's the moment where they don't treat it nicely. It just gets put into the dirt, into the harshness, for in our case agriculture, which is just a messy, dirty industry in a sense, because you're literally working in the dirt with spraying, etc. So that just the value of basically giving it into that, but also the time saving. I think for me a big learning was really to not be lazy about testing. So anything you can test in the office basically, or in the shop, or in simulation that you could test there, saves
Hmm.
you so much time in the field, because doing 100 tests in the office on a computer is so much faster than driving out there, doing something, and worst case even crashing something, then having to go back, repair it. So I really gotten like into this habit of like testing everything like so much more than, for example, doing university. Because in a research project, I always have this analogy, like in a research project, you do develop a system, it works 8 out of 10 times. That's totally legitimate to doing a research paper about and publishing it. And that's basically you completed the project. But in industry, it has to work like 1,000 out of 1,000, a million out of 1,000. You can't have it at a client that's, I don't know, you have a drone that crashed into a tree on the ditch. It's like, oh yeah, that's like it happens every 100th time you fly, it just crashes.
Yeah.
This is like, they will
It's
kill
not
you.
it's not it's not reliable, is it?
Yeah,
Yeah,
so this like level of testing you need to get this product like from 8 out of 10 to 99
10 out of
out of
10. Yeah.
100, but then 1,000 out of 1,000. It's just so much effort into just these getting it to these final stages. So I think that's also why these product life cycles, especially in robotics, they take so long. It's just because getting this level of reliability in is just a really long journey. And this was definitely the case for us also. I mean, the first prototype of, like, not the whole system, of course, like it is right now, but the first prototype having our navigation suite on a drone, navigating around some obstacles and trees. I think we whipped something up in a week and had a demonstrator for an interested customer in pretty much a week. But of course, then that was just the proof of concept. But then going to the next stage, that this whole thing became usable, and then literally the stage where now, this was just a really like a long and journey where you had to learn so many things about the systems, and there's no solution out there because it hasn't been done before. So you have to come up with all these solutions in the team, develop it, refine it, scratch ideas again, come up with new ideas, and iterate everything. And from hardware failures, or when you have electronics working with motors, with cameras, with computers, all of that kind of together with the software, it's a whole product that has to nicely work together, and that just takes time and needs testing and testing and testing, 100 times more testing.
I mean, even from a cost perspective as well, you could look at it kind of from that angle. And if you're going out and crashing drones every 10 minutes, it's going to cost you a lot of money. Whereas your simulation, running that test hundreds, thousands of times, making sure that it works in that sense is a lot better than running your hardware out there and crashing it into a tree or crashing it into
Especially
the
the
floor.
stupid stuff. I mean,
Yeah, yeah.
there's definitely this level. We noticed this actually quite quickly working with our drones. They rely pretty much completely on cameras for their whole navigation. So they have 4 cameras, and they
Mm-hmm.
perceive their entire environment with these 4 cameras. So we have GPS and stuff on board, of course, for global stuff. But the whole like navigation algorithm, obstacle avoidance, terrain following, all the AI features, all of that is really relying on the cameras. And we quite quickly noticed that the problems, or like the challenges against all the edge cases, you get them only pretty much in the real world.
Mm-hmm.
So we quite quickly went from just like doing simulation to actually doing real world testing, because it was pretty much impossible to get those issues in the basically simulation environment. But at the same time, there's just like stupid stuff you can just literally catch doing it in simulation. So
Yeah,
you have to find this balance. So you can't just be like, okay, I simulated it now for, I don't know, like half a year. I built a product in simulation, and now I can just give it to a client. So this also
mm-hmm.
doesn't work. So it's this,
Yeah,
you have to, I think, get the best out of both worlds. You really have to test in the real world, because anything that is simulated is not tested. It worked in simulation, great, but it's not tested really. But there is a lot of issues you can definitely find in simulation, and you do want to find all of those in simulation that you could have found. But yeah, as a startup,
especially
you don't have the money to crash drones all the time.
especially because you're working outside as well. If these were drones for inside a warehouse or something like that, they're controlled environments. Wind, rain, lightning. All,
Spray
all of these.
chemicals that you actually
Yeah,
spray around. And I mean, this is a spraying drone. So we are building 2 products right now, 2 main ones. But this is a spraying drone. It's literally spray and oil and stuff and the chemical ones onto the air that could, in theory, some of that can come onto lenses that you use for the navigation. You have to handle all
yeah,
of that, and good luck
yeah.
simulating that.
I'm with you. I'm with you. Next point in the podcast is really to ask you if there's anything that you'd like to highlight, anything close to your heart, anything that you think in the industry needs more light shone on it. This is basically your opportunity to talk about anything that you like in the industry, really.
I mean, the whole robotics industry, I mean, is super vast. But I think really what is close to my heart is also, of course, the agriculture industry. I think there is really right now a massive opportunity for investors, startups, people working in it, but also a big lag, because it's slowly catching up, I would say. Agriculture is pretty much technology wise 10 years or more behind other industries like defense. Means normally gets the best of the best technology, the most expensive stuff, the earliest. Then you have like mining, surveillance, where there's a lot of money basically in it. But agriculture is always a bit last. But I find it a bit of a shame because number one, farmers, they get affected by the whole climate crisis the most. For example, across the globe, among farmers, there's massive suicide rates because they lose their harvest and they can't pay back loans, etc. And it's solvable problems with technology. But they just fall under the radar because it's not the, I don't know, for techies somehow not the sexy industry to work in. And it's also, of course, a challenging industry because you have the growth cycles of crops and the slow margins because farming is kind of a small margin money-wise game. But it's the biggest scale industry, I would say, on the planet. I mean, every country, everything is, there's so much
Food,
agriculture in the world. So
food's
the
not going
scale
out
is,
of fashion, is it?
I mean, we will always need to eat.
Everyone needs to eat.
And people, I mean, everybody is like kind of interested in food. We care about what we eat, but then we don't really work or try to make basically the farming aspect better. And I don't know a lot of startup founders who actually work in agriculture. I know a couple, of course, also because I work in agriculture. So globally, I know a lot of startups in this industry, or probably most startups that work in that industry that do cool stuff. But compared to, I would say, robotics and the whole like AI industry right now, it's still only fraction. And sadly, I think investors and startups do kind of shy away a bit from it. But I think it's a fascinating industry to work in. Number one, like I said, the scale is infinite. So if you have a product that farmers love, they're a bit risk averse because, of course, their harvest depends on you then solving something. So it's not like a SaaS product you can just evaluate a bit, try out, skip to the next one if it doesn't work. If you actually use it on your harvest and the products don't perform, you can lose that harvest. So it is a risk for farmers to adopt new technologies. But at the same
Hmm.
time, if they see it works, if it solves a problem, an actual problem for them, they don't want to let you go anymore. And they really want to have these products then. So I think this matter of like impact you can create on an actual industry, on people's lives, on the planet as well. Because for example, I don't know, with our product right now, we reduce chemical usage by over 60% on average. I mean, even though if you still use, whether you use organic farming, also use chemicals, just organic chemicals, you still like, you can have a massive reduction in chemical use, like gasoline use, even if you use generators to power these things because it's off the grid and there's no electricity outlets. We normally reduce the gasoline consumption by 95 to 99%, for example, that they normally use. Then we have chemical reduction of 60%, water reduction of 90 to 95%. So the impact you can just make there from a sustainability aspect is massive. Then comes, of course, the health impacts you can make for people. For example, right now in across the globe, even in Switzerland, here at least they use protective gear. But in a lot of the world, they use like those knapsack sprayers. It's just basically they have these 20 to 30 kilogram backpacks with chemicals in it. They go into the fields and then they have those things, they just spray it. It's super
Hmm.
inefficient for the crops. The quality is horrible. And it's a
Hmm.
really bad job because the people, you're walking in the fumes, it's hot, you have this massive thing you need to carry. You might get a snake bite, that actually happens quite a lot. So it's a really bad working condition and nobody actually wants to do it anymore. So farmers even struggle. Even in India, there's a labor shortage in agriculture because
Hmm.
nobody wants to do these really tough jobs that people shouldn't anyway be doing it. So with new technology, you can really come in, make an impact, make it better for the environment, better for people's health. And then you can at the same time also educate people to have these autonomous systems that they can use these systems, have a better paying job. So you can get somebody from this horrible knapsack profession, basically knapsack spraying, re-educate them to become a drone operator in our case. I mean, there's all different kinds of in agriculture possibilities where you can innovate. But now they are like it's really this job nobody wants to do to become a drone operator, which is a great job. So you can keep people in the rural area. You can make it attractive again for people to work in agriculture. You can give them better professions. So it has this amazing like feedback cycle in this industry that as a tech startup you can do. But of course you need the people, talent that is interested in it, that do want to work in this and produce value and do the impact. And then of course also from the investment side, I think there has to be this shift in investors where they have this like more patient capital. Again, like deep tech, so robotics, slow industry, agriculture, slow industry, put it together. You really need the patient capital and a bit of a different mindset from investors because you won't get like a lift off in half a year after funding a startup. It's just impossible in this
Yeah.
industry. But again, like you have this long and more sustainable growth also as a company because you're building like more defensible products. So I think for investors, it's an interesting industry, but there's a lot of apprehension still about it, sadly.
Yeah, I'm with you. Definitely see it from the VC side and the investment side as well, which we are getting in more touch, in more contact with investors, with solo investors, with venture capital companies as well. So it might be worth, having that conversation around it when I'm exploring it as well and saying, what have you thought about the agriculture business? Because everyone's it's really, really saturated on the defense side, really saturated on the kind of manufacturing side as well. I think it does get overlooked, and it is a massive shame. But again, contributing to if you are interested in contributing towards those dull, dangerous, and dirty jobs, basically, and making sure that it's a machine doing it rather than an actual person, then it's the right industry to be in my opinion.
Yeah, because it's backbreaking. And people often are like, yeah, but don't you take then jobs away from people? Or
No one wants
they
to.
have
No
there's
one
like
wants to do them anyway.
unemployment. Yeah, that's the thing. Like nobody wants to do
Yeah,
them. And even like literally like you have the same. Like I've been talking to people across Africa, in India, where like when I tell
even in
people
the
there's a
US.
lab, yeah, when I tell people there's a labor shortage in India, people always think I'm crazy. But in
Yeah,
agriculture, there's literally a labor shortage.
yeah.
Farm owners can't find the help anymore to service their fields.
Hmm.
And I mean, I get it. I wouldn't want to do these kind of jobs because they're
Yeah,
backbreaking. They're bad for the health. Like it's horrible job sometimes that people
they
would
don't
need
pay
to do.
enough. Yeah,
They don't pay enough as well, so people can rather be like get a comfy job in the city compared to doing this backbreaking job in agriculture.
exactly. Why
Oh,
would people complain about a machine taking a job that isn't filled as well? That's
everybody's
that's
just actually everybody in the industry is just happy about it. They want this. I think that is just like one of those outside perspectives that is just pretty much like plain wrong.
yeah.
I think if you just think about it, it makes sense. Like, oh yeah, of course, like big, like, oh no, we could automation removes jobs, but in that case, I really think it's not the case. It just, and yeah, I think it can actually create jobs because you can re-educate people for these automated systems. But of
Hmm.
course, for that, you need like actually like high quality systems, fully automated ones. So the skill level and the education level to use these systems has to be quite low.
Hmm.
That's why I always think like automation, like automated systems, smart systems are super important. Because if it's a very like sophisticated from a using perspective system that needs a lot of skill and education and know-how, you can't really make an impact with this because the amount of people that then can operate these systems is too small. So
Hmm.
especially if you go into agriculture, you want to create like an impact. So you want to bring your system out in the large scale so a lot of people can benefit from it but also for that can use it. It has to be so smart that the operation is so simple that you can pretty much teach anybody to use it in a super short amount of time.
I mean, you've touched again on obviously a skill set that is going to be required as jobs get automated. There's going to be more jobs opening up for operators, for service technicians. Again, what kind of engineering skill sets are you seeing that are going to be really future critical for the industry as well?
I think, I mean, okay, there's one thing, of course, like operators for systems. I think the skill cap there is going to go down and down. I think there in the whole like robotics environment, I think it will become more of an operator, like literally like an overseer for the systems. So as the smartness and the autonomy level of these systems increases, the actual input that people have to do and like when you can, I mean, like let's say 10 years ago, if you had a drone, you literally had to manually on the joystick control the attitude of the thing. So it was like you had to be like full on there. Now with these systems, you select the field, you press start, this thing does its thing. We don't recommend people doing it, but they could put the remote control down, take a tea, and come back 5 minutes later when the system returns. It does its job. And so you don't really need this like low level input anymore and constant worrying and mental effort as well. But they get more and more automated. So for example, on the systems, we deliberately didn't choose to have like a refill station or something, just increases the cost for people. The operator basically all they have to do is, of course, be a safety pilot, check a bit that legally that's still required, but swap the battery in the tank out, the system goes again. So that's pretty much all they have to do. And I think the industry will go more and more into that direction. But on the other side, I think for engineers actually designing these systems, I think having a bit of a, you need a, I think, more in-depth knowledge, especially with all the AI tools. I mean, I have a love-hate relationship with those. They never really do what I want them to do, and I always get super excited, and then stuff doesn't work. They don't underperform, so I end up actually doing stuff myself.
Yeah, yeah,
But I mean, still, I think with all these, like, even like for robotics, I mean, in the past everything was like super like classical control theory, and then like things like computer vision, these things came in. Now reinforcement learning is a big topic, for example, or now it even goes into like those visual transformers where you could directly go from camera to low level motor feedback in one big AI model. But I think there, as an engineer, you will have to be able to know all those industries and then make educated decisions there, because I think, I mean, with this AI hype right now, people, of course, they try to solve everything with AI. And as much as possible, basically just make one model that does everything. But I think in nature, this is not how it works. And I don't think this is how robotics will work. For example, AI, it's always a bit of a trained black box. So it's, you have to really train it for things. And what you train it for, it can work well. But then maybe things come outside of the training data. So it's a bit unpredictable then. So it's a bit hard to be very deterministic. But of course, AI also needs a lot of computational resources. So, for example, if you do an analogy to like humans or mammals, we also have these different things. For what we see with our eyes and our brains, doing really like sophisticated computations of how to get from A to B, what to do. But then our nervous system, it's more like a classical control system in a sense. So you have the direct feedback through our spinal cord where you don't like, your brain is not processing and then giving it like this high latency feedback to it. We would just stumble around like crazy. But you have basically this different cascading kind of systems in your own body. Your feet, I mean, the sensors in your feet, and when you walk, detect things in the ground basically. And before you might even be able to, your brain might be able to process it, your spinal cord is already basically adjusting your foot. I think the same is in robotics. So you want to have these different things. So you need really sophisticated AI or computer vision based models. There's also different pros and cons again in that industry for different use cases. But you want to have this like smartness to do big decisions. But people shouldn't disregard the classical stuff, like the fully deterministic control systems, because they're, number one, they're like super efficient to calculate, so you don't need a lot of compute, but also you know exactly what goes on there, so you can do predetermined analysis whether the system is stable, how it behaves, and that has like a very I think especially in robotics, when you work in industry, a very reassuring feeling also when you build a system, because you know what's going to happen. Not it's like a black box and you hope for the you hope you have all the training data in. So I think it's really, as an engineer, you want to go into this hybrid approach and you want to understand the systems and then be able to really pick the right tool for the job. And I think that's how robotics will build and teams will do, and engineers do get more responsibilities, especially in startups, I think.
I think they're the best kind of talent within the engineering side that you're looking for as well. The ones that know how to work these new AI tools to however they want them to work, but also they understand the key fundamentals and the actual, the science, the physics behind what it is they're doing. The result comes out and they fully understand everything. Plus, if something goes wrong, they know how to fix it. That's one of the main things that I've come across anyway. I
Yeah, I think with
suppose.
this, the AI tools, especially nowadays, I think they can make you also a little bit lazy, because sometimes they do amazing work, but in the end, you still, I mean, you should at least, if you use them, you should still understand what they do and also to be able to guide them. And I think what will become really valuable and set like really the really efficient and good engineers apart from people they just randomly rely on AI to solve everything is people that actually understand the deep fundamentals of how things work. And then I think you can really use also these tools like for development very efficiently. But having only like a very like an overview knowledge on the topic and then using I think this is a very dangerous combination, and especially if you go into like industry robotics where like a failures actually have like can have real world consequences. I mean, robots crashing into things that could potentially lead to actually like serious injury, compared to like if you have a web app that crashes. Okay, it's inconvenient, maybe somebody might, even if it's a money app like a banking app, they might lose some money or something, but it's not going to injure people like physically. But if
Yeah,
you're in
yeah.
robotics, this can be like really catastrophic if people don't actually understand the systems they're building. So I think they are like really having this, for engineers, this deep knowledge about systems and still going really, even if you use co-pilots and stuff to understand actually everything they produce, improve it, better it, guide it, work together. This is going to be like super important, in
Suppose
my opinion.
that, yeah, no, I'm with you 100%. What I really wanted to move to was why do you think someone should consider a career in robotics today? Why is it so exciting for you? What's from your point of view, why is now the time to get into the industry?
I think to get really started on that, so let's say you're a bit younger, like maybe you're out of high school or even in high school. Uh, Number one, being able to start in robotics got so much cheaper and so much more fun because the
Hmm.
compute platforms you get nowadays, the NVIDIA Jetson series, Raspberries, the sensors, you can get this like super powerful robotics hardware and it's not that expensive. I mean, when I studied university, building a drone was like a big project.
Yeah, yeah, yeah.
Now you can just buy that. You can buy pre-assembled kits and just assemble together to get started, and then you can build on top of that. Or you can buy these Raspberries, these Jetsons, and you have this amazing compute platform, amazing open source ecosystems of all the knowledge that is out there. So the access to that industry got a lot easier for students, for people just being curious about it, wanting to start an career in it, also startups. It's not as expensive as maybe probably like 20 years, 30 years ago it was to do stuff. Even manufacturing, 3D printers, all that kind of stuff, you can just get started for really little money. But what like exciting part for me of working in that is I think really this creating part. So I think as an engineer, you can be really creative, and in robotics especially, the super creative industry. Actually, I mean, creative we all quite often think about music, art, etc. But I think in you can be creative in pretty much any kind of domain. But in robotics, you have this touch upon this in the beginning, this interaction of you code something. That's what I love about coding. You just basically type some stuff into a computer and you can create things out of just typing. You're writing some text basically and you create system behaviors. But then combining this with actually the real world, and then you have robots coming to life that do things, and you have this direct basically influence, and you can see these systems emerging out of basically those simple components. I don't know. I find this just like super fulfilling and fascinating. And yeah, for me, this is always a big dopamine hit when I see the things just like emerging out of it. And I know you're working the code, and nothing works, and suddenly it starts to work out, and the systems
Mhm.
connect, and then yeah,
Again,
systems
seeing that
emerge.
work that you're doing, yeah, coming to life. That's the main thing, isn't it? The kind of seeing the real world application of you typing something on a computer is crazy. I'm with you. I suppose from a SWIND point of view, what's next at SWIND? I know you probably can't tell me too much, but what's exciting about it? Why should people wanna come and take a look at what you guys are doing, potentially consider a career there as well?
Yeah. I mean, number one, I think we're really at the edge of basically drone technology, computer vision, AI for drones. We're working, I think, I would say agriculture together with maybe search and rescue, but search and rescue is always a bit more like a research thing topic. But we're really working in one of the most challenging environments for robots. I mean, agriculture is unpredictable. Every field is different. The scenarios change. It's dirty. And there's so many challenges in it. So it's this really fascinating industry to work in because it's just simply, I would say, the most challenging environment for robots to operate in.
Hmm.
So that's just for me personally. I love challenges, so that is a cool thing. As a company, yeah. So we're really going into the market right now. So our main focus is on India right now, but we do want to do stuff globally going forward. So I think for us, it's a really exciting part in our journey right now as we are really scaling our products into the market and having this like growth period now where it's not just basically done in small scale, but we see the impact in the world. More systems are getting deployed, getting used, getting the feedbacks from people operating our systems, the farmer stories that have been serviced by our drones. So it's a really cool moment right now in our journey, I would say. Yeah, so I think those two aspects are basically, I mean, the technology is fascinating and it's a really cool moment for us as a company right now as we enter this market, which is also for me right now a completely new chapter, going from this like really like early stage startup into the more, I wouldn't say we're scale up yet, we're still a bit small for that, but into the direction
Kind of
of this
growth,
scaling into
new
it.
growth periods. Yeah.
Yeah.
Perfect. And obviously with kind of growth periods, obviously become new hires that need to be made. What kind of people, skill sets are you looking for now and in the future?
Yeah, I think, I mean, like, we touched again on like robotics. You have the interaction of all these kind of different systems. I mean, we're literally working on, we have hardware, we have electronics, we have software development, we have operations, we have cloud infrastructure, basically also like new projects coming up from crop analysis. So this is our first project, Bumblebee, of really like the spraying drone, but the whole solution is a lot larger than just building basically one drone. So we really want to be the crop protection basically company, and so there comes crop analysis in it. So we have another prototype. It's not released yet, but just a hit basically for crop analysis, so using multispectral thermal imaging to detect diseases in plants before we can even see them with the eyes. Then you want to really have this connected into the cloud data processing. So I think like skill wise, pretty much anything you can think of is part of a company. Even like marketing. I mean, of course, like marketing is
Yeah,
super
yeah, yeah.
important. If nobody knows about you, nobody knows about you. We already have like a really cool guy doing like content and marketing for us. But I mean, this also needs to grow. So I think as a startup, literally like every role as you grow needs to be like filled and the teams grow. So definitely, I would say from skill wise going forward, we'll need everything. I think
Nice.
more from the personality, what I really always look in people is people that are deeply interested in things. Because I think you can learn anything. If you're interested and really have the grit, you can pretty much learn anything. So this curiosity and work ethic of people is really what I value. Taking initiative, wanting to learn more, learning next to your job, just educating yourself, still having this drive to work. I think people get attracted by startups quite often because they're not looking for the comfortable job, but the exciting one where they can learn, where they can grow the fastest. And that's
It's a certain
exactly
type of person that really.
because I mean, startup, it's a lot more, it's more chaotic, it's more messy, it's, you don't have the 9 to 5 job, it's, you have a lot more irregular working hours. But also, of course, like, for example, like my team, I love my team. We have a really cool one. Everybody is super dedicated to doing it. They love working on these problems, the statements. They don't shy away from putting some extra effort into making something great. Yeah, honestly, like, without our team, we would not have come to this point where we are right now. So, I think, I mean, in a big corporate, I think this is kind of like fizzle out, and because you're just, there's so many people. But in a small startup, every person that joins a team has a tremendous impact on the culture, but also the output of the company, what you can create. And that's why for us, we'd rather not hire somebody, but getting the wrong person.
Hmm.
So this cultural fit, number one, I mean, we are super diverse. I mean, we're like, we have a part of our team is in Zurich, part of it is in India. So we already have this basically cultural diversity in it. India itself is like a super diverse country. A lot of problems that we talk about culturally and diversity, it's not even a topic for them anymore. They've solved it like 1,000 years ago. So we have this really cool diverse teams, like from different characters, ethnicities, genders, like all of that together. So that's a lot of fun working like this, that everybody is like really different. But I think we all have this combined vision into this goal. And that then brings it all really together and focuses it. And yeah, I think in a startup, this cultural fit and attitude, this is just,
Huge.
and yeah,
Yeah.
and it's hard to put like a really like a hardcore definition on it, because it's, you're something you really just like feel when you talk to people and you interview them and you start working with them, where you really feel that person really has this energy to them and this curiosity and this drive. And some people don't have it. But yeah, we're really
No, I'm with
looking
you.
always for those people that have this something extra, I would say. Yeah.
Yeah, definitely, definitely. I suppose all that's left to do, Kevin, obviously, is to thank you for spending your time with me, for sharing your stories, your insights. How you got to where you are today. I'm obviously really interested in the agriculture side of robotics as well, but mainly on the robotics side. I'm going to be keeping a really close eye on SWIND and what you guys are doing over there. I think it's really, really important. Making some real world impact, and everything that we've been through today, I think highlights that, and the journey that you've been on to where you were to where you are now is obviously testament to where SWIND is going as a company as well. Really, really interesting, and thanks for your time, I guess.
Yeah, it was fun chatting to you. Thanks so much for having on us on here. It's always nice getting a bit of publicity, being able to talk about your project. As a founder, you can talk about it endlessly. There's no stopping you talking. It's always fun, just like sharing basically your creation with the world.
Yeah,
So thanks a lot for that. That
sharing your
was
baby.
fun.
No, not a problem. Thanks very much for your time, Kevin. I appreciate it, and we'll catch up soon.
Awesome. Thanks a lot. Talk
Cheers.
to you soon. Bye.